Alright guys, today we're going to talk about 3.7 Part A, Quadratic Inequalities. Solving a quadratic inequality requires that we locate any real zeros, and then we also have to determine if the graph opens up or down. And if it doesn't intersect the x-axis, then it's going to be completely above or below the x-axis. So some examples. If you're looking at this first one, the first thing we want to do is locate the real zeros. So that means we need to factor this. First, take out a negative, so we have a positive x squared. And then we can factor the remaining quadratic into x minus 5 times the quantity of x plus 4. That means the zeros are located at 5 and negative 4. And if we just draw a number line representing that, at negative 4 and positive 5 is where it's going to cross the x-axis. This negative out front in our quadratic tells us that this quadratic will open down. So if you just sketch a little upside down quadratic where it intersects through negative 4 and positive 5, then we're going to answer the question of when this function is less than or equal to 0. That happens over here when the x's are below negative 5 and when they're, below negative 4 and when they're above 5. So when you write your answer in inequality notation, your x is an element of the set from negative infinity all the way up to negative 4, including negative 4, because that's when it's equal to it, or 5, including it all the way to infinity. Looking at the second one, we're still going to do the same process, but we already have the whole function as an inequality rather than just a function notation. We're going to solve it for 0, so we can find those zeros. We'll start by adding x to both sides, and yours says positive 7, change that to a negative 7 out front, and it'll make it able to factor. And we're going to add 7 to both sides. At that point we have x squared plus 4x plus 4, and everything on one side, so now it's greater than 0. So we're going to factor. This is a perfect square trinomial, so it's x plus 2 quantity squared. We're looking for when it's greater than 0. So our zeros, the only 0 happens at negative 2, and it has a multiplicity of 2. So if we draw our number line at negative 2, that's when it's equal to 0, and we want it when it's greater than 0, so it's not actually equal to that point, so it's an open circle. This quadratic also happens to be positive out front. That tells you it opens with the end behavior of up, up. So if you draw in your quadratic, it's going to go through that, bounce off that 0 point, and a quadratic that opens up. And when we want to know when it's greater than 0, that happens every single point except where it's actually on the axis. So if we write that in interval notation, x is an element of the set from negative infinity all the way up to negative 2, but not including it, and then going from that negative 2 to continue through to infinity.